Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Unfortunately, this puzzle does not have the rules provided in the Sudoku puzzle, but we have them on the Logic Masters Germany forum here. So, what we're going to do, apologies for that, I just realized I moved something else in a wrong place, but we'll get to that eventually. Anyways, let's get to the rules. Let's get to the actual puzzle. It's called Ratio Killer Sudoku X. And this is a very easy puzzle. And it's by Kibo. And these are all normal rules. We have normal Sudoku rules apply, which means in every cell in the grid, we need to place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is called a box here. We have positive and negative diagonals. Actually, this is the negative diagonal, and this is the positive diagonals, where you can't have repeats along these marked diagonals. So similar to rows, but basically it's along the diagonals. You cannot have repeats along these specific diagonals. And obviously you know it's 9 cells long, so therefore since it's no repeats, that means it must be the digits 1 through 9. We have black crop key dots, where the digits that are separated by a black crop key dot must be in a 1-to-2 ratio between them. We also have German whisper lines here, which are the green lines, where so actually, let's give an example of the black crop key dots. If this were, say, a 4, this would have to be in 2 or an 8 to maintain the 1-to-2 ratio between those digits. For German whisper lines, adjacent digits on a German whisper line must have a difference of at least 5. So, for example, if this were 3, this would have to be 8 or 9, because those are the only digits which are in a 1 that are 5 or more away from 3. And finally, we have killer cage Sudoku, where the digits in a cage, the digits in the cells of the cage must sum up to the number in the upper left corner. So these two digits must sum up to 7, these two must sum up to 12, these two must sum up to 17, these two must sum up to 14. So, for example, if this were, say, a 5, this would have to be a 7 here, because these two digits must add up to 12. And I think those are all the rules. Let me double check. We did German whisper, crop key dots, positive diagonal, negative diagonal, killer cage. Yep. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the first thing that comes to my mind, actually there's a couple of things. First thing that I see, though, is, there's many things. These two digits add up to 17. There's only 2 unique digits that can ever add up to 17 with each other, and that would be 8 and 9. Also, on a German whisper line, you can never have a 5 on the German whisper line, because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. And if you add 5 or more to 5, you get 10 or more, which is not digits. Therefore, we know 5 has to be on this diagonal, and we know 5 has to be on this diagonal. Well, where's the only place it can be on the diagonals? Can't be here, so 5 can't be here. So 5 must be one of these 3 digits. 5 can't be here, 5 can't be here, so 5 has to be one of these 3 digits. Well, the only one that fits both is here, so this is 5. This then cannot be 5 and 9 to add up to 14, it's 6 and 8. The 6-8 pair eliminates 6 and 8 from the rest of the row, so this is 9, this is 8. This could be 3, 9, 4, 8, or 5, 7. 5 and 7 are ruled out because this digit cannot be 5 or 7. This can't be 4, 8, so this must be 3 and 9. And this must be 9, which makes this 3. This is in a 1-to-2 ratio. It cannot be 3 and 6. It cannot be 8 and 4. It has to be either 2 with 1 or 4. So 2 has to be one of these two digits. What else do we have? We have 9 cannot be... Actually, let's go here. This digit is in between 3 unique digits on a German whisper line. Same with this, same with this, same with this. The thing is, to be next to 3 unique digits on a German whisper line, you have to be either 1, which can be next to 6, 7, 8, and 9, or 2, which is next to 7, 8, or 9, or 8 and 9. But 8 and 9 cannot be here, therefore this must be 1 or 2. And therefore the digits next to it on the German whisper line are the digits 6 through 9, possibly. But 9 can't be along this diagonal because we already have a 9 here. This could be 6, 7, 8, and 9. So 2 of these digits are high. This digit is high. Can this ever be 2 high digits here? And okay, so on a German whisper line, you'll always alternate between low digits and high digits. Because what digits can be next through 1 through 4? 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9. So if you have a digit from 1 through 4, it'll always be next to a digit from 6 through 9. So that way we know we alternate between low digits and high digits. Now check 6 through 9. If you check 6 through 9, what digits can be next to those? 9 can be next to 1 through 4, 8 can be next to 1 through 3, 7 can be next to 1 or 2, and 6 can only be next to 1. So you'll always alternate between low digits and high digits. Therefore, whatever digit this is, these have to be the opposite set. Well, if we tried to have 2 high digits here, the problem with that is that it would basically... You would have in this diagonal 5 high digits, which you can't have because the high digits are 6 through 9, and that's only 4 digits, right? So you'd have 1, 2, 3, 4, 5 digits which require 6 through 9, which is not allowed because you can't have repeats. Therefore, these must be low digits. The low digits, the only high digit that can be next to 3 low digits is 8 or 9, and we can't have a 9 because of a 9 on the diagonal. So this is an 8, which means this cannot be 8 here. This is a 6, 7 pair. 6 and 7 have to be next to 1. It can't be next to 2. 6 can never be next to 2. The 6, 7 pair also eliminates 6 and 7 in the rest of the diagonal and the rest of the box. So this is 8 or 9. This can't be 1. 8 can only be next to 2 and 3 here then. That forces this to be a 1. That leaves this digit as a 4. That means on one of these digits here, you have to have a 4, right? Because 4 cannot be on this diagonal in this box. 4 would have to be here or here. Well, 4 can only be next to one unique number on a German whisper line, so it can't be in the middle. And it can't be here because this would have to be next to a 9, but this can't be a 9 here. So 4 has to be one of these two, and it must be next to a 9. So this is 9. That means this is 9, which means it's next to 2, 3, and 4 possibly. This is 4 here. So it can also be next to 1. So 1, 2, 3. This is 1, 2, 3, 4. 1, 2, 3, 4. But 1 cannot be here or here because of the 1 in the column. We have a 2. In fact, we have a 2, 3, 2, 3 pair in column 7, which eliminates 2 and 3 in the rest of the column. This can't be 2 or 3. This is 4. So this can't be 4 here. This is 2 or 3 in a 1 to 2 ratio with something. If it's 2, it can't be 4, so this must be 1. If it's 3, this has to be a 6 to be in a 1 to 2 ratio with it. This 8 eliminates 8 here, so this is 6, which makes this 8. The 6 eliminates 6 here, so this is 1, which makes this 2. This can't be 1 or 2, so this must be 3. That's 3 in the corner. We celebrate. That eliminates this 3 in the corner, so this is 2. This is 3. Remaining digits, so... This cannot have... Well, it could be. Okay. This digit cannot be 1, 2, 3, or 4 because 1, 2 in the same row with it, 3, 4 in the same diagonal with it, which you can't have repeats. So this must be a high digit, which makes this 6 through 9. This must be a low digit. It's next to 3 unique digits, but it can't be 1, so this must be a 2. 2 can only be next to 7, 8, and 9 on a German whisper line. So this is 7, 8, and 9 if it's 3 unique digits. Therefore, we have a 7, 8, 9 triplet in column 3, which eliminates 7, 8, 9 in the rest of the column. So this can't be 7. This is 6. This makes this 7. The rest of the column must be 1 through 5. This is 2 through... this can't be 1 or 3. It must be 1, 2, 4, 5. But this cannot contain a 2 here. And this can't be 4. This can't be 5. So, and this is 1, 2, 4, 5. This can't be 2. We have a 1, 4, 5 triplet in column 3, which eliminates 1, 4, 5 in the rest of the column. This can't be 4 or 5, so this is 2. We have a 1, 2, 4 triplet in this left central box here. So that eliminates 1, 2, and 4 in the rest of the box. This can't be 1, this is 5. So this can't be 5 here. Where is the 7 in this left central box? Can't be here. Can't be any of the 1, 2, 4 triplets, so it must be here. So this is 7. That makes this a 6. Where this can't be 7. This cannot be 3 and 4 to add up to 7. It could be 1, 6, or 2, 5. So this is 1, 2, 5, or 6. What else do we have? None of these can be 9 on this German whisper line. So this must be 8. This must be 7. This must be 9. This 9 eliminates 9 here, so that's 8. Where is the 9 in this upper left-hand box? Cannot be here because of the 9 in the column. Can't be here, so this must be a 9 here. And the rest we okay, well, where are the 1 and 3 along this positive diagonal? Cannot be, it has to be these two. This can't be 3 because of the 3 in the row, so this is 1, this is 3. That makes this 2 and 5. And now we can do just normal Sudoku. So let's start with, there's a lot of 5s. Okay, I guess we'll just start with row 1. Remaining digits in row 1 are 5, 4, 5, 6, and 9. 5 cannot be any of these 3 digits, so where's the 5? It must be here. So this must be 4, 6, and 9. That means this can't be 4, this can't be 9. Remaining digits in row 2. We have 3, 4, 6, and 8. This can't be 6 or 8, so this is 3 or 4. This can't be 4 or 6 because of the 4, 6, 9 triplet in the box, so this is 3 and 8. This can't be 3, so this is 4, 6, and 8 here. And this can't be 8 because of the 8 in the column. Okay. Row 4, we have the digits 2, 4, 5, and 7 remaining. This can't be 4 or 5, so this is 2 and 7. We have 2, 4, 5, 7 here. This can't be 2 or 4. This can't be 2. And this seems, the rest seems okay. Column 2, let's do column 2. We have 3, 4, and 6 remaining. This can't be 4 or 6, so this is a 3, which means this can't be 3, this is 4. This can't be 4, so that's 6. This can't be 4 or 6, so that's 8, which makes this 3. 4 eliminates 4 from being this pair, so this is a 1, 2 pair now, which eliminates 1 and 2 from the rest of the box. This can't be 1, so this is 4, which makes this 1. So now we have remaining digits in column 1 are 3 and 5. This can't be 3 because of the 3 in the row, so that's 5 and 3. Remaining digits in column 2 are 4 and 6, and either of them could be 4 or 6. Remaining digits in row 5. We have 1, 2, 3, and 7. This can't be 1, 2, or 3, so this must be 7. Which means this can't be 7. This is 5. This can't be 5 or 7, so it's 4. This can't be 4, 5, or 7, so it's 2. Which means 2 can't be here. This is 7. We have 1, 2, and 3 remaining in... Wait. I see a problem. Huh. Interesting. Oh. Okay. The problem was this can't be 1 and 3. I missed the diagonal. Apologies for that. Sometimes, yeah, you'll have that issue. Okay. We gotta go back. Okay. What do we have on this diagonal? It's 1 and 6. Well, still the same thing. This is 1, but this has to be 6. Ugh. Apologies for that. That was a pretty bad mistake. Anyways, this does leave this as 2 and 5. We didn't actually use this very much. Anyways, let's go through here again. Row 1. It has to be 4, 5, 6, and 9. Again, 5 cannot be any of these 3 digits, so it must be here. This can't be 6 or 9, so that's 4, which makes this a 6-9 pair here. Row 2, well, 4 can't be here. That means 4 has to be here. This is 3. 3 can't be either of these, so this must be 3 here. That makes this a 6-8 pair, and this can't be 8 because of the 8 in the column, so this is 6, this is 8. So that's slightly different. Column, this still can't be 4, so this is a 1-2 pair. Which means this can't be 1, this is 4, which makes this 1. So this is all very similar. It's just that I messed this digit up. But I didn't really use that digit much. This is 3, 5 again, so this must be 5 and 3. This is 4 and 6 again, and either of them can be 4 or 6. Okay. The rest of this upper central box has to be 1 and 8, and either of them can be 1 or 8. The rest of row 3 is 5 and 7, and either of them could be 5 or 7. Rest of row 4 is still 2, 4, 5, and 7. And this can't be 4 or 5. 2, 7, 2, 4, 5, 7, but this can't be 2 or 4. This can't be 2. We had row 5 again, but this is still the same. 1, 2, 3, and 7. Well, this can't be 1, 2, or 3, so this is 7, which makes this 5. Again, that's 4. This is 2. This is 7. So this becomes, neither of these could be 1, so this is a 2, 3 pair. This can't be 2, so this is 3, which makes this 2, which makes this 1, and that's 2. That leaves that as an 8 here. The 8 eliminates 8 here, so this is 1 and 8. The rest of row 6 is 1, 3, and 9. This can't be 1 or 3, so this is 9. This can't be 1 because of the 1 in the column, so that's 3, which makes this 1. Rest of column 4 is 1, 3, and 5. This can't be 3 or 5 because of the 3, 5 in the row, so this is 1. This can't be 1 or 3, so it's 5, which makes this 3. Rest of column 5 is 2, 4, 6, and 9. Okay, 2 cannot be here or here, so 2 must be here. This is then 4, 6, or 9 as possibilities. This can't be 9, so this is a 4, 6 pair here. In row 9, which eliminates 4 and 6 in the rest of the row. We have 5 and 7 remaining in row 9. This can't be 5 because of the 5 in the column, so this is 7, which makes this 5, which makes this not 5, so that's 7 and 5. That leaves in column 8 the remaining digit of 4. That 4 eliminates 4 here, so it's 6 and 4, which makes this 6. That makes this 9 and 6, which makes this 4. Remaining digits in column 6 are 8 and 9. This can't be 8 because of the 8 in the row, so this is 9, this is 8. The remaining digit here is a 6. The remaining digits here are 9 and 7. Apologies for some of these just mental errors here. I don't know, just didn't see it correctly. Missed the 3 here. But yeah, that's how you solve it. Pretty straightforward. Um, yeah, it's just basically using German whispers and the diagonals to restrict things a lot. And I guess the killer cages, right? Yeah, just used all the constraints very well. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.